In this video, we will finish our discussion of section 11.7. We're talking about these type of weird odd graphs that kind of show up that we should talk about how to relate it maybe using some of these formulas to understand what it may be. So we have an r equals 3, so this definitely has to be cylindrical. So let's think about maybe something we can actually get out of this to relate back to something we know. Well, if I square both sides, I get r squared equals 9. Well, I know r squared by the formulas is the same thing as x squared plus y squared, and that's a circle, right, with a radius of 3 centered at 0. So this is a cylinder, right? And I have so if I have my plane, I have some circle here with a radius of 3 going up in each direction and down in each direction. So one thing I like to think about when I'm missing a variable, because I'm missing z here, is I get all of z. That's why it's up and down. If it's missing, I get every single z. And that's why it's an up and down cylinder like that. So even when I'm thinking here, right, I have r theta z. I get all of r, or I get r is 3. That's why it's only the radius of 3. And then I get all thetas. Well, that's why it's a circle, right? That's why it goes around. And I get all z's. That's why it goes up and down. So there's two different ways to think about it. You can use it, convert it to here, think about it being a circle and you get all z's. Or you can think about back here, thinking you get all. Right, the next one is with the theta, so I'm going to show you all those different ways. How I want to think about this first is theta is pi over 4. So, okay, think about this. We have some kind of graph. And theta, that's all we get, right? We have a theta. That's all that's set. But I get all r's and I get all z's. So I get all r's, so that's all of the radii, and then z's are up and down, so I get a plane. And the only thing that defines the plane is that's the angle between itself, the plane, and the xz plane, or the x-axis there. Right? How could I convert and maybe think about this instead? Well, I know that tangent theta, I'm going to take tangent of both sides. I get tangent of theta equals, okay, well, that is 1. Tangent of pi over 4 is 1. And if I look at that, that's tangent is y over x equals 1. Well, that's y equals x. Right? That's this line. I'm missing z, so I get all z's up and down. The line y equals x is that straight line in the xy plane. It's sitting there. And since I get all z's, that's why I get the whole plane. All right, so this is a plane. Okay. The next one, we have rho is 2. This one, how I like to think about it is go ahead and square rho. So squaring rho, we get rho squared is 4. Well, I know rho squared is x squared plus y squared plus z squared. So anytime I see rho, that's what I'm trying to go for. This is a sphere where r is 2. Right? This next one, we've got a few more. This one, if I replace my r squared with minus x squared minus y squared, right? And maybe we could even think about it moving those over and making them positive, x squared plus y squared, and then minusing that z, and then we could even rewrite z as x squared plus y squared equals, and I'm going to write this, and it's going to seem silly, but it's okay. There we go. That should be a minus 4. There we go. Check my algebra, it's right. But this is z equals that is if I look back at the formulas from section ago, this is a paraboloid in that form. We actually did an example that looked a lot like that. All right, the last one on this page, we have a few more on the next. Takes a bit of some algebra approach to it. Secant, I'm going to change it to cosines because I don't think usually in secants. So we have that instead. So I'm going to multiply both sides by cosine. So r equals 4 cosine theta. All right, so then I'm going to multiply both sides. This is going to be weird. I'm not squaring. I'm multiplying both sides by r. So I get 4r cosine theta. All right, well, if I do a bunch of conversions there, r squared is x squared plus y squared. Hold on, there's a truck passing. Right, then r cosine theta here, back to polar, right? That's an x. So I get equals 4x. Right, this is actually it's going to turn out to be a cylinder with a circle base. But I'm going to show you how to get this thing in standard form. I'm going to minus 4x. I'm going to put a space there. But I'm going to put a plus space on this side too, right? Because this is 0 now on that side. What we do to complete the square, if you'd like to see more, I have a video on this to show you where it comes from. But I cut this in half. So I take negative 4, I divide by 2, and I square it. And that tells me what goes in the space. So negative 4, that number, divided by 2 is negative 2, squared is 4. So I'm going to put a 4 here. But it's an equation, so whatever I add, I got to add to the other side. This will factor to x minus 2, or whatever half is, plus y squared equals 4. Now, if I can see now that this is a circle, just shifted to the right too, so that's actually a cylinder on my graph. You're not going to have to do this much ever going forward. It's just nice to convert, because what we're going to end up doing is we're going to do integration over polar. You guys have done that already, hopefully in Calc 2, and if not, you'll get a taste of it, because we're actually going to do it over cylindrical, which is the extension. We'll be okay, but some of this stuff is going to be useful there. All right, I have a few more examples here that go pretty quick. It's a lot of algebra. So what I'm going to do first, that truck is coming back by, revving, of course. One sec. All right, so if I multiply both sides by row, not square, I know it feels like we're squaring, but I'm going to multiply it by row. We get 4 rho cosine phi. I replace rho squared with x squared plus y squared plus z squared. I replace rho cosine phi with z. That's a conversion. And then I can do that same thing. And what happens here is we get x squared plus y squared plus z minus 2 squared equals 4. This is a sphere. All right, let's just shift it over. I would check out if you need this completing the square. I know I'm like, this is like all these prerequisite topics are just understood that you can do. And unfortunately, I know that's not always the case, but it's just how the game is. So you have to do the reviewing as you go along. This next example, I'm going to replace cosecant with 1 over sine phi. Replace secant with 1 over cosine theta. I'm going to multiply both sides by that denominator, so I get phi sine rho sine phi cosine theta equals 2. And then that's x. That's just the formula for x. So this is a plane in 3 dimensions. I know quickly you were probably like, it's a line, but remember it's a plane in 3, because you get all y's and all z's. We have 2 more here. First thing we're going to do is factor that, or distribute, anti-factor, I guess. So I'm writing that out. Okay, so first thing we're going to do is this is actually r squared. That first thing, it's a formula for r, but squared, minus, right? And this becomes 2. That is the formula for z. And then it's squared equals 1, right? I replace r squared, I get x squared plus y squared minus 2z squared equals 1. From the video a couple days ago, or a couple videos ago, we have a one sheet. Hold on for the, oh, they went the other way, perfect. Hyperboloid. It's a one sheet hyperboloid. 2 squares with a minus, with a constant, tells me that it's a one sheet hyperboloid. Okay, we have one more to convert. We're going to factor this thing. We can do that, right? Just algebra on r's. And then we do this, r equals 1, r equals 2. And we can see that this is going to be like a cylinder with r equals 2 like above, and then another cylinder inside. The graph itself is actually both of them. So we get a weird donut thing, cylinder, just an infinite wall in both directions with an inner circle on the inside.